Now, how to do direction cosine? How to do also for direction cosine? Now, you have to do some things very important. Let's say if vector A is equals to AI, let me just do it this way: AXI plus AYG plus AZK. They can ask you what is the direction cosine of this vector. Now, we normally denote direction cosine with L, M, and N. There are three values we use for direction cosine. Now, how do we actually do this direction cosine? Just two things you need to know. Number one, the magnitude of vector A. That's the first thing, which is the square root of AS, you square it, plus AY, you square it, plus AZ, you square it. That's the magnitude. Then ensure there's no minus inside this magnitude, because there's no negative inside magnitude. Everything must be positive. Even though we have negative numbers here, if you find their magnitude, they will turn to positive. So taking note of that is also very important. After you have gotten the magnitude, next you will get the coefficient of IJK. Coefficient of what? IJK. For example, now the coefficient of I is this AX, coefficient of J is AY, coefficient of K is AZ. That's the second thing. They will now ask what is the direction cosine. Look how to do it now. Let's look at a typical question now. A very good question. What is the direction cosine of vector A equal to, let's say, 2I minus 3J plus K. What is the direction cosine of this vector? The first thing I'm going to do, what is the magnitude of A? That's the first thing you get. The magnitude of A is the square root of, what is the coefficient of I? 2. You square it, plus, coefficient of J is negative 3. Don't take the negative, because if you square negative 3, it will change to positive. So forget about negative sign when you are doing magnitude. Just forget about negative sign. Just take away the 3, you square it, plus coefficient of K is 1. So take that one, then you square it. So this one is going to give me something like 9. Okay, this one is 4, 9, 1. So that's 14. So that will give me root 14. That's root 14. So the magnitude of A is root 14. So the direction cosine now, which is L, M, and N, will be, just look at them. L is this coefficient of I over this magnitude. J is coefficient of, M is coefficient of J over this magnitude. Then K is coefficient of this, N is coefficient of K over this magnitude. Those are their respective direction cosine. So we're going to have for our M, the first direction cosine is that we have 2 over the magnitude of root 14. And the second one, which is M, is minus 3 over root 14. And the third one will be the coefficient of K over the magnitude. So this is how you do direction cosine. The first thing you do, you just find the magnitude of the vector. Then the next thing, divide this one by the magnitude. That is for the first direction cosine. Divide this other one by the magnitude, second direction cosine. Divide this last one by the magnitude of the whole vector. That is the third direction cosine. Let me look at just one more example. Now let's look at the direction cosine of the vector A equal to I plus J minus 2K. What is the direction cosine of this vector? Now look at it. First thing, you get the magnitude of A. That's the first thing you do, which is the square root of, coefficient of I is 1, J is 1. So let's do coefficient of I squared plus coefficient of j squared. I told you for this, don't take minus, just forget about the minus. For magnitude, just take only this coefficient of k. I'll give us root 6. So next, the correction will be L M N. Now, what's the meaning of this L M N? L is the direction cosine of the s-axis, which is the coefficient of I over the magnitude. M is direction cosine of the y-axis, coefficient of j over the magnitude. K is direction cosine of the z-axis, coefficient of k over the magnitude. So that's all. Now, sometimes we could do it this way. They'll tell you this M, this L is cos of the angle between this vector A and the s-axis. That's actually this x. This L you are seeing there. Then the M is the cos of the angle between y-axis, angle between the y-axis and this vector. Just like what you are trying to look for naturally. What you are trying to look for, this direction cosine is actually the angle made with this vector A. And let me just show you so that you just understand the meaning of the direction cosine. It's just like the angle made with this vector A to the x, y, and z axis. This one make the angle made with that vector ax to the x-axis, the angle made with that to the y-axis, the angle made with this to the z-axis. So if I ask you, what is the angle made with this vector to the z-axis? So you just use this to get it. How will you use this to get it? Just put cos theta here and find theta. That is all. Just replace this k with cos theta, then find theta. You get the angle made with this vector and the z-axis. If I ask what is the angle made with this vector and the s-axis, just put cos theta here and find theta. Then you get the angle made with this vector and the x-axis. So that's why some textbook will give you this way. The correction cosine for the s-axis, they put cos alpha. They put cos alpha there, which is same to this 1 over 6. Then for the y-axis, they put cos beta, which is 1 over 6 as well, or 6. Then for the z-axis, they put cos gamma. It's still the same thing. This cos beta is our m here, cos alpha is our L, there's cos gamma is our k there. The why sometimes we could just use L, M, N. So if they ask you, look for the direction cosine of this vector, what they are telling you to look for is this L, M, and N. If they not ask you, what is the angle made with this vector to the x-axis? They ask you now, what is the angle made with this vector to the x-axis? Just look for the direction cosine of x side, which is dividing the coefficient of s by the magnitude of the vector. Then after this, you just find the cos inverse of this side. You just find the cos inverse of a direction cosine. You get the angle made with that vector and that axis. This one is x axis, this one is y axis, this one is z axis. So lastly, without wasting time, just get this. If you want to get the angle made with this vector and the z axis, find the cos inverse of this. For y axis, find the cos inverse of this. For for s axis, find the cos inverse of this. You get the angle made with this vector to the s, y, and z axis. But if you want to get the direction cosine, just do this L, M, and N, which is the coefficient of s, y, and z divided by the magnitude of that same vector. Simple as ABCD. Thank you.